Why do some problems seem impossible until we change the way we think? Have you ever faced a puzzle that seemed unsolvable until a new idea suddenly clicked? Emma looked at the small wooden box on the table. The rich scent of cedar filled the air, mingling with a hint of varnish. She ran her fingers over the intricate carvings, feeling the grooves and patterns beneath her fingertips. The wood was smooth yet cool to the touch. Inside was a prize she had been eager to get, but she needed the right code to open it. She sighed and whispered to herself, "All right, let's figure this out. Can't be that hard, right?" She remembered that our thoughts are built from basic ideas called concepts. Concepts are like the building blocks of thinking. Trying to think of a common code, she considered examples, or prototypes, which are typical examples like 1, 2, 3, 4, or 0, 0, 0, 0. Maybe it's something simple, she thought. But her usual ways of thinking, known as schemas, weren't helping. Schemas are like mental habits or routines. It's like trying to open a door with the wrong key. You can keep trying, but it won't work until you find the right one. We can change them by absorbing new ideas without changing our thinking, assimilation, or by changing our thinking to include new ideas, accommodation. Emma realized she might need to adjust her approach. Maybe I need to think outside the box, she thought with a smile. Determined, she decided to try every number possible, like a computer going through all options using an algorithm, a step-by-step method. She began entering codes one after another, but the box remained locked. Her fingers started to ache from pressing the tiny buttons, and the soft beeps from the keypad began to blur together. She muttered, "There must be thousands of combinations. This could take forever." Growing impatient, she said aloud, "Perhaps I'll try any code that pops into my head." This is using a shortcut called a heuristic. Heuristics are like mental shortcuts that save time, but aren't always accurate. It's like guessing the answer on a test when you're not sure. You might get it right, or you might not. For example, she thought, most people use their birthdays as codes. That's relying on a general idea about people, which can be misleading. This is called the representativeness heuristic. She then tried 2020, the year she graduated. This is like using the availability heuristic, which means using the first idea that comes to mind because it's recent or memorable. It's like grabbing the first tool you see in a toolbox, even if it's not the best one for the job. At one point, Emma thought, "I've tried 5 odd numbers in a row. The next one must be even." She shook her head. "That's silly. The box doesn't know what numbers I've tried." This is the gambler's fallacy, believing that if something hasn't happened recently, it's more likely to happen next, even when each attempt is independent. It's like thinking that after flipping a coin and getting heads 5 times, tails is due on the next flip, even though the odds are still the same. She yawned and considered giving up. "But I've spent so much time on this," she thought. "I can't quit now." She realized she was falling into the sunk cost fallacy, sticking with something just because of the effort already spent. It's like continuing to water a dead plant because you've cared for it so long. Emma remembered how she had solved similar puzzles before. This mental set made her try the same methods again and again. The numbers etched on the box influenced her thoughts through priming, where what we see affects what we think about. Wait, she thought, am I focusing too much on numbers because of these markings? She took a deep breath and said, "I need a new plan." She used her planning skills, called executive functions, to organize her thoughts. The frontal lobe, located right behind the forehead, acts like the brain's manager. It helps us plan, make decisions, and control impulses. Emma tapped her forehead lightly, as if to jog her brain into action. She murmured, "Come on, brain, think." Instead of only thinking about numbers, convergent thinking, she began to consider other possibilities, divergent thinking. What if the code isn't a number at all, she wondered. She realized that being stuck on one idea was holding her back. This is known as functional fixedness, when we can't see other uses or solutions because we are focused on one way. It's like looking for your keys when they're in your hand the whole time. It's like opening all the windows to let fresh ideas in, she thought. Chuckled. "I've been so blind." Then Emma noticed tiny letters, EMMA, engraved near the lock. Her eyes widened. "Wait a minute," she whispered. "Maybe it's not a number." She typed in "open." The box made a satisfying click, and the lid lifted smoothly. Inside, the prize gleamed, 2 small, ornate keychains. She picked them up. They felt warm in her hand. There was also a small note that read, "Sometimes the answer is right in front of you." She laughed and said, "All this time, I just needed to think differently. My brain was both the lock and the key." She felt a surge of excitement. The real reward was the change in how she thought. It was like she reached a new level in a game. Have you ever faced a problem that seemed unsolvable until you looked at it differently? Maybe next time, try stepping back and considering a new approach. Next time you face a tough problem, remember, sometimes the answer is right in front of you, if you see it differently.